So in the session, let's look at cleaning our data sets and, in a sense, destructuring some of the structures that easily arise in our data. So shown on screen is from our data scratchpad. You can see a so-called clean data set where you've got the column names up top and you've got columns of data. And as you page through this, you'll see it's a very basic, boring table. And so basic and boring is a thing that machines love to read, right? So especially in a relational database, nice, boring, regular tables like this, columns of values where you've got a nicely defined set of column names and everything sticks with that. That's very much machine readable. And fine, these tables may be cross-linked, and we'll talk a bit about how to represent more complex structures a bit later. But this is very much the way most of our relational databases work. And in recent times, there have been other proposals for databases, especially if you look at the JSON-like databases. What do they call those? I think graph databases. So in those databases, you have more of a JSON-like structure, JavaScript object notation, so you can support tree-like structures in those databases. However, still, I believe something like 99% of databases run on this basic tabular style of approach. And in a sense, my own bias is towards this because over time I've learned how to represent more complex data structures using tables. And as I said, we'll look at some examples of how to do that. But on going into this kind of coursework on data analysis and then looking at some of the data sets that people are routinely using, especially in Excel, it's been it's been quite eye-opening to say the least, the amount of variety in the way people store their data. And I'll just put one of those up here. So if you look at this data set, it's very much not like the tabular set of data I showed just now. In this case, and this is one of our postdoc students, Anu. So she's got a data set where you can see lots of empty space, and you can see you've got certain columns, but then there are certain rows and columns which imply a kind of hierarchy or substructures within the data set. And in this case, you've got multiple tables in the same sheet. Um, and there are a number of different issues and challenges before a data set like this can become machine readable. And in fact, I took something like half an hour just reading it, trying to understand what I was seeing there before, and actually wrote out a series of issues that I was seeing. So I identified something like 7 or 8 different types of substructure within this sheet. And then before we talk about some of those types of structures in there, just to say there is a reason for it, right? In an Excel spreadsheet, people are not using it as if it's a relational database or something like that. There often isn't the intention to upload to any kind of database. Most of the time, the Excel spreadsheet is the database that people work on quite happily, and they design reactors and everything. I've even seen someone solve PDEs in an Excel spreadsheet, but I would never recommend that. But still, people are using Excel spreadsheets to represent sophisticated structures, all within this framework of tables of cells. And that's because, of course, you can use the formatting and you can represent a good sense of the data to someone. You can use it for communication and you can copy and paste into your documents. So there are real reasons. So I'm trying to say I'm not necessarily criticizing data that's as complicated as this, that has this level of challenge for it to become machine readable. And I think most people, this is a kind of human way of storing data. And I think a human being would find it quite unnatural to try and represent data in tables like this, and especially for the more sophisticated structures, this poses a significant challenge. So let's look at some of the sophisticated data structures that we might want to represent and why we end up with Excel spreadsheets like that. So on screen, there's this presentation that I give as part of a course, but I'm just going to focus in on some of the basic, focus on the issues that we are talking about now in this video. So first off, just the basic thing, here's a flat list. So you've got columns of values and you've got column names up top there. So that's the standard thing. And then when you want to represent a more sophisticated structure, something that's more tree-like, then you begin to wonder, well, how could I do that with a basic table? So let's take the example of a to-do list. So we know we can define the things we need to do at a high level, and then the tasks may often be broken down further into subtasks, and those subtasks further to subtasks. And there's actually no end to it. You can go as deep into your subtasking as you want. So shown on the right here is just an example of that. You want to prepare your grant proposal, so you have to define objectives, methods, budget, and then in defining even one of those, there are further subtasks there, and that can get pretty deep. So that's just an example of what we just said. Now, if you think about this, how would you represent this in a table, right? How would you represent it in a way that it represents that something is a subtask of something else? And it's quite an interesting thing. So maybe pause the video and try and think of a way to represent this in a table, right? To do it efficiently in a table. So pause the video now. Think about how do you capture the tree-like nature of these rows? Okay, now assuming you've paused and unpaused, here's a solution. Before we look at the solution, some proposals have been, well, why not make enough columns so that the subtasks you populate those in later columns and so on. So you could do that, but then that means you'll have big white spaces. So if you have a deeply nested task, then you'll have lots of along that row, you'll have lots of wasted space there. So instead of doing it that way, to represent a tree in a single flat table, we can simply include a parent ID. So we had that example, prepare a grant proposal, and then that has the ID of one. And then we have a subtask to this task, so define the objectives. So we simply specify a parent ID. So we say this activity is a child of this parent of one, parent one. So if you look up one, then that's parent one. And using this simply this extra column of parent ID, you can create an infinitely deep parent-child tree of relationships. And so this structure efficiently captures even a tree structure. So that is one example of a more sophisticated data structure, which can still be represented as a table. Then sometimes it's not enough to do it that way. Sometimes there's a whole object, and I didn't say that objects we think of objects. The standard view of it is that in your table, the columns are the attributes and the rows are the objects. So if you pick a row, then you are talking about a certain thing. So you are trying to represent something that exists in a sense in the real world, and then that thing has different attributes. So the columns um, give you the values of the attributes of that thing. So, for instance, here you've got different people. So the objects here are people, and the attributes, the first name, last name, national ID, those are the attributes of the people. So the row is the object, and the columns are the attributes. So sometimes you want to the parent-child relationships. They can, of course, in a very explicit way. In this case, you can have parent-child relationships among these, but you may also want to associate um, other objects with the original object. So you may have a person uh, with a parent-child relationship to another type of object. So I'm trying to say now that here we had this in this task list, the parent-child relationship was with the same type of thing, which was the task, right? You have tasks and subtasks. So in this case, you have people as the objects, but you may have people have medical records, they may have hotel reservations, and there may be multiple hotel reservations for each person. So how do you represent this now, right? You can't refer in the same table to a parent ID. So maybe again, pause the video and think about how you would represent this. Okay, so the solution to this is to create a so-called foreign key. So like we had the concept of a parent ID, you can create a reference where it's known that that column is specifically referencing a different column. So in this case, the medical records have, in a sense, a parent column, but it's pointing to a different table. So it's pointing to the people column. And so you can repeat that. You can associate medical records or hotel reservations to the people column. And so you could have multiple parent, so-called foreign key references. So foreign key, so your key now, instead of calling it a parent, we'll just call it a key. So this key is pointing to a foreign parent, so a parent in a different table. So a foreign key is how we connect ourselves with another table there. Um, Now, this we could have a one-to-one relationship. So it could be for one person, there exists one medical record. And of course, in the record, you may have multiple entries. But of course, so that would be a one-to-one relationship. Then, if you think about over the lifetime of a person, they may have multiple hotel reservations. Now, this structure already does support that. So one-to-one, clearly you can do it using this approach, and also one-to-many. So one person having many hotel reservations, you would simply repeat the person ID. You'll have a different entry for a different hotel reservation, but with the same person ID. So that's one-to-many. Now think about many to many. How can you represent, so if you have, let's think about writing an article to be published in a journal. So one person may write many articles in different journals. So in principle, that could be one to many. So one person writes many articles. But one article could be written by more than one person. So you can easily get three people on a journal article. Or in physics, they sometimes have these massive lists of authors involved in one article. So you could have people involved in many articles, and an article could have many authors. So that is a many to many relationship. So now again, let's pause. Please take a minute and think about how could we ever represent a many-to-many relationship? Because that's not possible with a simple foreign key here. So you can't have multiple people, right? The key problem now is that you can't have multiple people here referencing one hotel reservation because in your people table, there's no reservations reference. In your reservations, each reservation can only reference back to one person. So how can you support a many-to-many relationship? So pause the video, think about that, and try and sketch out a solution. So here's how we do many-to-many, right? The only way to support many-to-many is through a linking table. So in this example, you've got this is for if we are ordering something, so ordering purchases. So a customer may place many orders. So here, if you look, there's a customer with ID 5678, and they've got two different orders here. And in an order, you may have multiple products. So the only way to support that is with a linking table. So for many-to-many, you need an additional table simply to do the linking. So in this linking table, you can have your customer appearing more than once, and you can have the same product appearing more than once for different customers. So that's how you can support many-to-many relationships. So the reason I'm saying all this is just to point out that it is possible to represent highly sophisticated data structures simply with tables, with regular boring tables. You can do it. Um, so that is why those of us more familiar with databases are quite used to just representing things in simple, clear tables, right? And that is where we get something of a disconnect with spreadsheets like this and the attempt to represent the one to one to many, many to one sometimes um, in one Excel spreadsheet like this. So it's also to if we understand that those types of relationships are what we are trying to represent, then that also helps us in figuring out, well, in understanding that that is what we are trying to. Sometimes just being aware that that's why we are putting in a merge cell, and so we are trying to show that there's a certain value that applies to multiple other entries and so on. So that is, and also that our object needs to be row oriented if we want to represent it in a machine readable form. So the whole point here is we have lots of messy data. We have, and I won't say messy, I'll say we have data that has some sophisticated data structures in them, right? So data like this is fairly typical. So this is just one of four in the last week or so. I've had four different people give me four data sets, and each of those had all these kinds of data structures embedded. And so a significant challenge now is in representing this, in translating this to the machine readable form before we can even begin our data analysis. Right. And there's great value in being able to convert it to a machine readable form because then we gain access to not only storing our data efficiently in databases and being able to query that data in different ways, but also machine learning is quite tabular, right? It's quite organized into features and labels, and so it opens up different forms of analysis and modeling and machine learning and all of those good things. So that's why it is valuable to try and clean up our data. So towards this now, there is a fairly significant update to the data scratchpad. So you'll see that now instead of having all those different those accordions that you have to keep clicking through, we now have these sort of drop-down menu types of things. And what we also have is an issue detector. So I'll show you what that means. So let's load up a messy data set. So let's put in Anu's set again. So that's loaded there. And then if we say here, detect issues, it's going to list all the issues that it's found here. So, and yeah, there are 18 issues that it's picked up here. So if we click on one of those, then it loads up this interface and tells us the first issue is that in one sheet, I believe there are multiple tables. So this code I've written tries to parse the data, P-A-R-S-E. It tries to parse that data and look for these kinds of structures that make it challenging to machine read it. So one of the first issues is that in one sheet you seem to have multiple tables. So it's highlighted one of the tables, and then I see my drop down is missing. Just fix that little bug, but you can choose you can get highlights for the different tables that are present there. So that's one issue, the need to extract a set of data into its own table from a substructure. Then another issue is, yeah, just figuring out where the header, the column names are sitting, and where the body of the text is. So that's another one. What direction is it? So sometimes you actually do have inherently two-dimensional data where you've got two independent variables, and databases and machine learning doesn't really like that. That expects you to have objects running down, and so there are ways to handle that. Um, so blank rows, aggregates. So quite often you'll have your spreadsheet, and at the bottom you'll want totals and averages and maybe standard deviations. So these kind of aggregate rows, you want to cut that out because we're going to have that in our analysis anyway. Then you'll sometimes find a series of things. So you'll have, for example, month, there'll be month dash year or something, and there'll be many of those. So it picks up that there seems to be a series in one of the rows. And then there are issues with range values. So sometimes you just have a value more than 5 or between 3 and 10 or something like that. So there are all these issues it picks up, and then it, uh, it 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 will try and suggest a way of handling that so that we get our nice regular tables. So we are working through each of those issues, and so it will pick up an issue. You read what proposal it has to handle that issue, and then you'll be able to click on apply just to apply that change so that you're able to work with that data again. Okay, so that's what we are working on currently. Uh, so we'll release, we might need some of the issues are quite sophisticated and deep, and we'll need to spend some time talking about how to handle that. But for now, what you can do is understanding what we need in terms of a machine readable data set that's ready to go for machine learning and so on. If you can start just doing that on your spreadsheets so that we can do the analysis, then that will be a way to make progress. So we're trying to do two things in parallel. Number one, we're trying to set up a method which will help you do the extraction and the cleaning and the destructuring of that data. So we are trying from that side, but if you can also take your data and format it a bit more machine readable like, then you'll also be able to just go skip the other steps and go on to the analysis and the model development and so on. Okay, so there'll be more videos coming along that describes this further. So thanks for listening.